Okay, in this video I'm going to finish up the section on exponential functions, and we're going to look at applications. And really, as far as applications go, these are pretty straightforward. We're just using some formulas. The hardest part about this first part is just knowing the different parts or the variables that make up each formula. Notice here it says after t years, so t is time. The balance A in an account, so we're calling that A, our balance, at basically the balance at time t. In an account with principal P, really principal is what the starting amount is, like when you deposit money into a bank and then you want to start earning interest on it, so that's your principal P. And then the annual interest rate, so that's the amount of interest you're earning per year, and that should be written in decimal form. And so those are the parts, or the variables. And I just want to make a comment here. What we're dealing with here with these formulas is compound interest. And really, compound interest is just interest on interest. For example, if you deposit your some money into a checking account in most banks these days, at the end of each month you'll get a statement, and they apply interest each month to your account based on the average balance in the account during that first month. And so then the next month you'll be earning interest not only on what you had to start with at the beginning of the month, but you'll earn interest on whatever interest you earned the first month. So it's this idea of interest on interest. Okay, so I'm going to make a little chart here. So it says for this first formula here, for n compounds per year, we're using this formula, A equals P times 1 plus R over N quantity, that quantity to the NT power. So in this formula, we already know T is years, A is the balance, P is the principal, and R is the interest rate. N is actually the number of times per year. It says here N compounds per year. It's the number of times the interest is compounded per year. So in the example I gave you when it was monthly, N is 12 because 12 times a year they're applying interest to your account. So if they use the word annually, that means N is 1. They're applying interest to your account once each year. Semi-annually, basically every 6 months, twice a year, they're applying interest to your account, so N is 2. Quarterly is 4. Monthly is 12. And daily, they use the number 365. Alright, so, and then for continuous compounding, we use this other formula, A equals P times e to the RT power. It's what I call the Pert Formula. You may have heard of Pert shampoo, or you may not have. But anyway, I call it the Pert Formula. So let's look at some problems now. On number 1, it says determine the balance A. So notice we're looking for A, excuse me, at the end of 20 years. So in this problem, T is 20. If $1,500 is invested, that's our P, at 6.5% interest, so that's going to be written as a decimal. That's our interest rate, R. And if it's compounded quarterly, then N is 4. So 4 times a year, they're applying interest to our account for these 20 years. So you should write down the formula, and then just make sure you plug in the numbers in the correct place. So P is 1,500. Again, that's the starting amount. R is 0.065 over N, which is 4. And then that's to the NT power. That'd be 4 times 20. And then just be careful when you put this into your calculator. The thing that you have to really watch is this part right here. You want to make sure that it's taking that everything in the parentheses there to the 80th power. You don't want it to take it to the 4th power and get some answer and then multiply by 20. So watch that when you're put it into your calculator, you want to make sure you're getting $5,446.73. And notice I've rounded to the nearest dollar here. Alright, so you may want to try it with n equals 12 and then check what I have to say on the computer or on the video here. Alright, so we're using the same formula. I'm going to go ahead and plug in all the numbers. So notice n is 12 this time. That's only changed so far. And then instead of 4 times 20, it's 12 times 20 since our n is 12. So here you should get $5,484.67. So notice whether they're applying the interest quarterly or monthly. It makes some difference over 20 years, but not a significant difference. The more money you're talking about, the bigger deal that would be. Alright, let's move on to the next problem. Oh, we also had to do the same thing for continuous, if the interest is compounded continuously. So here we're using the Pert formula. And so, of course, again, P is 1500, R is 0.065, and T is 20. Again, put that into your calculator and make sure you're getting the number I have here. Again, I want to remind you, you're going to do the 1500 or type that in, and then you'll hit second ln, and then you'll put in the exponent 0.065 times 20, all inside parentheses. Just one parenthesis around 0.6 or 0.065 times 20. Alright. And it also depends on your calculator. On some, like the TI-83, you got to be a little bit more careful when you're putting in exponents. Alright, let's look at number 2. It's really very similar. Just notice the interest rate's 5%, and our starting amount is a lot bigger, $20,000. So if we're compounding semi-annually, well, first of all, 20 is our time, 20,000, that's our principal, and R is 0.05 here. So semi-annually, that means n equals 2, and so we're going to be using this formula if interest is compounded semi-annually. And so let's go ahead and plug in the numbers. 20,000, it's going to be 0.05 over 2, and then that's 2 times 20 will be our exponent there. Go ahead and put that into your calculator and make sure you're getting $53,701.28. And then finally, let's see, on this other part, we're going to have n equals 12. So let's go ahead and plug in the numbers. And on this one, you should get $54,252.81. So again, over the 20 years, it does make some difference. It's not a huge difference, but it does make more of a difference here because we're investing $20,000, which is more than what we were investing before, which was $1,500. You know, of course, you always want to get as much as you can out of the money that you invest. All right, let's move on to the next problem. Both of these are really just very straightforward formula types of problems where you're going to just have to plug a number in and find what you're being asked to find. So here it says the exponential function f of x equals 42.2 times 1.56 to the x power models the average amount spent, f of x. So f of x is the average amount spent in dollars at a shopping mall after x hours. That's interesting. What's the average amount spent to the nearest dollar after 3 hours at a shopping mall? Well, I don't know how accurate the formula is, but we're going to go ahead and let's see. Notice here the average amount spent is what we're asked to find, right? That's what we're finding. And then x is 3. because it's 3 hours. So we're just going to plug 3 into this function here. And so this is our function. Let's go ahead and plug in 3. And you know, you might want to stop the video, put that into your calculator, and you should get $160.21. Alright, so again, I would encourage you to try number 4 and then watch the video. Okay, so here it says, in college we studied large volumes of information that unfortunately we do not retain for very long. This function describes the percentage of information, f of x. So f of x is the percentage of information, let's see, that a particular person remembers x weeks after learning the information. So x is the number of weeks after you've learned the information. It says substitute 0 for x and find the percentage of information remembered at the point it is first learned. Well, let's plug 0 into the function. This is our function. This is f of 0. And again, I want you to put that into your calculator and you should get 100. So what they're saying is, after we just learned something and no time has passed, we're going to assume that we will remember 100% because we just learned it. So I don't know if that's always true, but we're going to go with that. And then it says find the percentage of information that is remembered after 2 weeks. Alright, well, let's see what they have to say here. So let's plug in 2 here. And again, you might want to try that and then watch. And you should get 49.43. So about 49%. So if you learn something, 2 weeks later, you'll remember about half of what you learned. Interesting. Alright, that's going to be it for this video.